45. Write a balanced equation for each of the following nuclear reactions, and then we have letter C. So in this case, neptunium, which is 239, forms from the reaction of uranium-238 with a neutron, and then spontaneously converts into plutonium-239. Okay, so seems like there's two parts to this question, right? First, neptunium is going to form from a reaction of uranium-238 and a neutron, and then it's going to convert into plutonium. So we got to work one step at a time here, right? So let's do equation number 1. Now, equation number 1 is saying that neptunium-239 is going to form. If something is forming, that means that you're producing it. And if you're producing something, PP, producing, is going to be on the product side. So in this case, neptunium-239 is going to be on the product side, and this reaction, the uranium-238 with a neutron, is your starting material. So this is your starting material. Okay. So whenever we are dealing with nuclear reactions, we write these balanced equations with our nuclide notation, which basically have 3 components to them. I like to draw them as a box like this. Now, let's start off with uranium-238, because this plus the neutron, so this plus another box, another 3 boxes, right, is going to yield that neptunium. But let's start off with the uranium, right? So we got uranium-238, and the element identity always goes in the big blue space here. So we got big U, U for uranium. And the number that they give us, because it can change, this is always the mass number. The mass numbers are always the bigger numbers out of these 2 slots, and the mass number, since it's bigger, it goes on the top. So I'm going to write 238 on the top. But now the question is, who or what number goes here? Well, these are always your atomic numbers. Right? And these atomic numbers, they are very special numbers, and they're very unique to each atom. So I have to go on the periodic table to see what atomic number uranium is. And uranium, if I can find it, there it is. Uranium is number 92. It's always the whole numbers on the periodic table. Now, this uranium-238 is going to react with, so plus, a neutron. So, got to get another box out here, and we got to draw what the neutron notation is like. Well, a neutron is just a particle, right? So, it's N for neutron. And remember, neutrons are neutral. So that means it's got no charge. So all the N's, right? Neutron, neutral, no charge. So that means that it has an atomic number of 0, because the atomic number are always going to be the number of protons and electrons. But if it doesn't have any protons or electrons, it's going to be 0. And now, since a neutron is in the nucleus, right, you got one particle, the neutron being in the nucleus, so that's why a neutron is always a 1 up on the top. And now these two will combine to form neptunium-239. So here's another box, right? And we just got to write neptunium-239. So kind of like the same idea as how we did the uranium, right? So neptunium, some of these I don't use quite often, but neptunium is NP, uppercase N, lowercase p. They're telling us that the atomic mass is 239, so that goes in the upper right-hand corner. And I'm going to look for the periodic table for what atomic number neptunium is. It's right next to uranium, and that's number 93. Now, if this is the case, if we're fully balanced, all of the top values on the left side will equal all of the right values, right? So let's see, 238 plus 1, think of the yield sign as like an equal sign. So 238 plus 1 is 239, so that looks good. But on the bottom, 92 plus 0 is, not 93. So that means that we're missing another particle. Generally, if your numbers aren't matching, you need to add another particle on the product side. So let's figure out who that product is. So just like we said, the top numbers are equal, right? 238 plus 1 is 239. So this has to be 0, right? Because 239 plus 0 is 239. 238 plus 1 is 239. So they equal. And now 92 plus 0 is 92. So 93 plus what will get me to 92? Negative 1, right? 93 minus 1 is a 92. But now the question is, who is this? The only negative particle, that's an electron, also known as a beta particle. So whether you want to use it as an electron, whether you want to use it as a beta particle, that's up to you. But then because of that, you have an option of saying E for electron or B for a beta. Me personally, I like to use the B, but you could use the E, that's fine. And now equation 1 is perfect. But now here comes equation number 2, because we are not done. Equation 2, if we read it from the beginning again, it says that this neptunium-239 forms from this reaction, and then it will spontaneously convert. So when they string this along and then spontaneously converts, who spontaneously converts? It's the neptunium. So now we have to make an equation between neptunium-239 and converting it into plutonium-239. So let's go for it. We already have all the information for our neptunium. So neptunium-239. We know that that's NP239. 239 and a 93. Okay, beautiful. And now this will spontaneously convert. So I'm making a product, and that's going to be the plutonium now. So let's write that out. Plutonium. Poor Pluto. Got his name as an element, but they took it away from the solar system. But I think it was very short-lived. Right now, these are your cloud elements, right? Neptune, Pluto. I think those are the only two that made it. But I'm looking at uranium, Uranus, I guess. Ooh, I'm starting to make connections that I've never seen before. But other than that, that looks like those are the only three. So no Marsium, no Earthium, Jupiterium. That would be pretty cool, though. But anyway, let's keep going. I'm looking at the periodic table. Plutonium is Pu. They should have called sulfur Pu, because that one smells. But Pu is plutonium. They're telling us that it's a 239, so that goes up on the top. And the atomic number for plutonium is 94. So let's just see if this is balanced. 239 with 239. Okay, that's good. But then 93 to 94, it seems like I have to add something on this side to make it work. So let's add that one more box, and let's see if we could find out what particle that is. Generally, if you're spontaneously converting, you're decaying, which means that your particle is going to be on the product side. Now let's see, 239 equals 239 plus 0. And then 93 equals 94. Yep, it's the minus 1 again. So it's the same as before. We're going to have a beta particle, or an electron. And now, we are finally done with this problem. Whew! So there's your two equations. I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe if you haven't. If you liked the video as well, it just gets the word out there that this YouTube channel exists. Thank you so much for all your support thus far on this journey. And it's because of you guys that make the channel what it is. So thank you, thank you, thank you. And I'll talk to you soon, okay? Have a great day. Bye-bye.